So yesterday we were talking about linear quadratic systems. So linear quadratic systems, once again, that was when you had a linear equation, such as a line, like we have it here as y equals 2x plus 4, and then a quadratic equation, such as y equals x squared plus 3x minus 8. And you were seeing when is that linear and that quadratic system, when are the linear and quadratic functions equal to each other? So we're seeing what points do those two equations equal. For example, if your quadratic looks like this, and then your line like that, we have 2 points at which our quadratic and our linear equation are touching. There, we want to find what those 2 points are. It's not always a situation where it is 2 points, but most of the time we will come across that situation where we do encounter 2 solutions. So, because we're looking for when these 2 equations are equal to each other, when they're the same, all we have to do is we have to take the linear equation of 2x plus 4 and the quadratic equation of x squared plus 3x minus 8 and just set them equal to each other. Set them on each side of an equation or an equal sign, and then we need to solve this. So in order to solve, we have multiple methods. We have our quadratic formula, square, we have factoring. Any of those methods can work. What we need to do is we need to get everything to one side. We need to get all of our stuff to one side in order to start. So I'm going to start by subtracting my 2x to get it over. Now, because it's a 2x, I have to look for what like term to subtract on with my quadratic. So it's going to be that 3x. So my 2x subtracts. So I have 4 equals x squared. 3x minus 2x is just 1x minus 8. So 4 equals x squared plus 1x minus 8. Once again, though, I want to get everything over. So that includes that 4 as well. So I'm going to subtract the 4 as well. And because it doesn't have an x, I know it's going to go with that 8. So 4 minus 4 gives me 0 equals x squared plus 1x minus 12. Alright, there I have my quadratic. Now I need to solve this quadratic. Once again, we have a couple methods. We have quadratic formula, we have complete the square, we have factoring, graphing. All those are different methods we can use to solve this quadratic. Looking at this quadratic, and looking because my numbers do seem pretty small, pretty simple, I am going to try to solve this by factoring my quadratic. I know yesterday we did a lot of quadratic formula, which is perfectly viable, perfectly okay and acceptable. I'm going to try factoring this just because I think it's a little bit easier and will be a little bit quicker. Now, once again, though, we have to remember when we factor quadratics, not every quadratic is factorable. So not every quadratic that we encounter like this might have a solution. So that's why quadratic formula is a little bit more viable, because quadratic formula will always find your answer, whether there's an answer or not. While factoring, sometimes you might encounter something you just, that's not factorable, and I can't think of my solutions. I am going to try to factor this. So we remember factoring. Because I don't have a number in front of my x squared, I can use my short method. So I'm going to put negative 12 on top and 1x, or just 1 on the bottom. I have to think 2 numbers that multiply to get negative 12, add to get 1. So 2 numbers that multiply to get negative 12, add to get 1. Well, I can think 4 times negative 3 equals negative 12, and 4 plus negative 3 equals 1. So I know 4 and negative 3 are my 2 factors. Because I don't have that number from my x squared, I know this is going to be my shortened version. I don't have to do the long split the middle method. So I know I can just factor this straight into x plus 4 and x minus 3. So I factored my quadratic and I have these 2 parts. And when we did factoring, we knew we could set each of those parts equal to 0. It was called our 0 product property, where we could take one factor of x plus 4 equals 0, and the other factor of x minus 3 equals 0. Once again, you could do quadratic formula, you could do complete square. All of these are working for me to the same exact answer. I just thought this one would be a little bit quicker. So x plus 4 equals 0. I just need to subtract 4, and I have x equals negative 4 as one solution. And then plus 3, and then plus 3. X equals 3 is my other solution. So I have x equals negative 4 and x equals 3. Awesome. But we're not done. Once once again, if we think back to those linear systems of equations, when we got those two answers, but we're not done with those two solutions. Because once again, each of these are a coordinate point. So there's a coordinate. It has an x and it has a y for each of those two spots. I only have two x's. I need to get my two y's. So I need to figure out what are the y's for each of those points. The easiest way we did this in December for these systems of equations is you take that value and take that value of 3, you take the value of -4 and plug it back into the equation to get y. So for this one, we can choose either equation to plug it into. It doesn't matter if it's the 2x plus 4, it doesn't matter if it's the x squared plus 3x minus 8. You can plug either of those values in for your x. I personally am going to choose the 2x plus 4 because I think that equation is easier than dealing with my quadratic. So I need to figure out if y equals 2x plus 3, or 2x plus 4, I'm sorry, I'm going to plug 3 into that and see what y equals. So 2 times 3 is 6. So 6 plus 4 is 10. So I know this coordinate for 3 is 3, 10. That is one of my coordinates for my solution. That is one of the spots I have. I need to figure out what is my answer for -4 as well. I found the y for 3. Now I need to find the y for 4. I'll do that down over here. So once again, I'm going to use that same easier quadratic, or same easier equation of 2x plus 4. I just need to plug -4 in for my x. I'm just evaluating my equation at that point to get my y. 2 times -4 is -8 plus 4. So I have y equals -4. So this coordinate would be -4, -4. And so those are our two coordinates we got for the two solutions of our system of equations. That quadratic and that line touch at 310 and -4, -4. Awesome. Now let's think, how many possible solutions are there with a linear quadratic system? If we think about our quadratics, when we use our quadratic formula, when we use factoring, when we use complete the square, we had 3 possible numbers of solutions. The most common one was 2. Think about your quadratic, it's going to touch that x-axis at 2 points. But sometimes there's only one solution to your quadratic or to your quadratic formula. You just touch the x-axis at that one specific point. Just went down, bounded off that x-axis, and then went back up. That was okay. Sometimes we solve quadratics and we only got one answer. Not as common, but most of the time we got 2, but sometimes. And the last option was you had a quadratic, you had that x-axis, and they just never touched. We had none. No solutions. That was when we had like the square root of a negative number was when we would get no solutions. So anytime you had to take the square root of a negative number, we just had to give up. We said there was no solutions to the quadratic. Linear quadratic systems of equations work the exact same way. If you think about it, that x-axis is just like a line. So you can touch that line at 2 points, you can touch that line at 1 point, you can touch that line at no points. All of those are viable systems or viable solutions for a linear system, linear quadratic system. So it's okay to end up with 2 points. It's okay to end up with one solution. The only time you'll end up with one solution is if both of your answers end up being the same. For example, if you have to take the square root of 0, you get one solution. If you have to take the square root of a negative number, you get 0 solutions. And if you have to take the square root of number of any other type of number, any other number greater than 0, you'll get 2 solutions. So we're going to look at one more final example of linear quadratic systems, so one other example, and then you can begin on practice. So we've solved the system. Y plus 3x equals 2, and y equals 4x squared plus 13x plus 18. Now this one, if we notice, looks a little bit different from our last one. If we look at our last problem, we had y equals 2x plus 4, and y equals x squared plus 3x minus 8. If we look, our linear quadratic, or a linear system, a linear equation, is different. Rather than being y equals 3x plus 2, is y plus 3x equals 2. That 3x over here is with our y. It needs to be on the other side. But this is a simple fix. We know how to move that 3x over, so I'm just going to subtract 3x. And so my new equation is y equals negative 3x plus 2. The reason it's negative 3x and plus 2, I can combine them, is because 2 is a constant, negative 3x is a variable. They're not going to combine into like terms. So I'm just going to keep y equals negative 3x plus 2. Now that I have y all by itself with both my quadratic and my linear equation, now I can go to my set them equal to each other, start solving for my quadratic, start finding that solution. So I have negative 3x plus 2 equals, once again, I'm setting it equal to my quadratic, my 4x squared plus 13x plus 18, setting them equal to each other. I need to get everything to that one side, everything over. So I'm going to add 3x. Which gives me 2 equals 4x squared. 13x plus 3x, once again, those are my like terms, gives me 16x, then plus 18. And then lastly, move that 2 over. So I have 0 equals 4x squared plus 16x plus 16. So 4x squared plus 16x plus 16. All right, we have everything all by itself. Now we can start to solve. We did factoring for the last one, so this one we can do quadratic. You can take it, the good old quadratic formula route. Once again, quadratic formula, it's opposite of b plus or minus the square root b squared minus 4ac all over 2a. So we have all that. We need to figure out what is that a, b, and c. So my a I have is 4, my b I have is 16, and my c is also 16. And I can start substituting that into my quadratic formula. So here I go. I have opposite of b, so opposite of 16 plus or minus the square root of b squared, so 16 squared, minus 4 times a, which is 4, times c, which is 16, all over 2a, 2 times 4. So we plugged in our points into our quadratic formula, we plugged in our a, b, and c, and now we just need to start simplifying. Once again, we always want to start simplifying that square root first. That's going to make it the easiest. So let's start off by finding what is 16 squared. So 16 squared gives us 256. So negative 16 plus or minus square root of 256. And then I'm minus 4 times 16. So I'm going to figure out that type of half mix. So negative 4 times 16 is also negative 256. So I have 256 minus 256 all over 2 times 4 is 8. So once again, I've only squared them by 16 and multiplying these three terms together, following my order of operations. I need to simplify the rest of that. So 256 minus 256, pretty simple, is just 0. So I have the square root of 0 equals 8. And knowing what I have in here, knowing what I have in that square root, once again, can already tell me how many solutions I have. Because if I take the square root of a positive number, so square root of a positive number will give you 2 solutions every time. Square root of 0 will give you 1 solution, and square root of a negative number will give me no solutions. So I already know I have 1 or 0 solution. 1 solution because I have 0 under my square root. So 16 plus or minus square root of 0 equals 8. Well, square root of 0, 2 numbers I multiply to get 0, or 0 and 0. So it's 16 plus 0 equals 8. It doesn't matter if I add 0 or subtract 0. It's still going to be negative 16. So negative 16 plus 0 over 8 is going to be the exact same thing as negative 16 minus 0 over 8. And once again, this is why I'm getting that 1 solution. So really, I only need to solve one of these. So negative 16 over 8 gives me a solution of negative 2. So x equals -2 for my quadratic formula. Once again, I know with my line, if I were to sort of draw it, if my line, let's pretend, looks like this, my quadratic, I'm going to say, looks like this. They're just barely touching at a single point, and that is my one solution. I know that point is at x equals -2, but I need to figure out what is the y value at that point. Once again, in order to find my x and my, or in order to find the y, I just want to plug it back into one of those easier questions. My easier of my two equations is definitely going to be my linear one. So y equals -3 times -2, plugging the -2 value into that point, plus 2. -3 times -2 is equal to +6. +6 plus 2, so y equals 8. So my final one solution for this quadratic system, or linear quadratic system, is just going to be -2, 8. From here, you can begin to work on your practice that the sub should be able to hand to you, and then I will see you again on Thursday for those of you who are absent tomorrow due to your land lab stuff. But we will talk about this once again on Thursday, and then we will go from there. So have a good rest of your day.